Hello everyone. My name is Pramod Jinagara Srinivasaya. I'm a triple graduate student at California State University, Sacramento. In this presentation, I'm going to talk about graphene can create hot carrier cells in photovoltaics. These are all the topics I will be covering in this video. Firstly, I will give a brief introduction and history about graphene, followed by its properties and application. Furthermore, I will discuss about how a solar panel will work and how graphene can improve its performance and efficiency. Moving on, I will talk about advantages and its limitation, and then recent development in this area, and finally conclusion. The name graphene is derived from the word graphite, and the suffix "ene" tells that carbon contains numerous double bonds, and each atom in graphene sheet is connected to its three nearest neighbors by a strong covalent bond. As you can see in the figure, the carbon atoms are arranged in a two-dimensional hexagonal lattice. Graphene can be thought as a single layer of graphite with a thickness of just one atom. There was a potential existence and production of graphenes for decades. It was unknowingly produced in smaller quantities for centuries through the use of pencils and other similar applications. The graphenes theory first explored by P.R. Wallace in the year 1947. Later it was rediscovered by Andrew Jim and Konstantin Novoselov at University of Manchester in the year 2004. In the year 2010, both of them were awarded with Nobel Prize in Physics for their groundbreaking experiment regarding the two-dimensional material graphene. Coming to the properties of graphene, firstly I'll be explaining about structural property of graphene. The carbon atoms in graphene are arranged in hexagonal lattice, with each carbon atom bonded to three neighboring carbon atoms through strong covalent bonds, as shown in the figure. Graphene consists of single layer of carbon atoms with a thickness of only one atom. This makes graphene the thinnest material known to exist and gives its unique electronic and mechanical properties. The carbon atoms in graphenes are arranged in a flat planar structure with a high degree of symmetry as shown in the figure. Graphene exhibits several unique electrical properties due to its unique two-dimensional structure. Graphene is an excellent conductor of electricity with a high electron mobility that is several orders of higher than most metals. The electron mobility of graphene is 15,000 centimeters squares per volt second. It has a zero band gap, meaning that its conduction and valence bands meet at the Fermi level. This results in linear dispersion of energy near the Fermi level. This unique electronic structure gives rise to high electrical conductivity and make it suitable for high-speed electronic devices. Mechanical property of graphene. Graphene is the strongest material known to exist, with a tensile strength of over 130 gigapascal, which is over 100 times stronger than steel. This strength is due to the strong covalent bonds between carbon atoms in the graphene lattice. And it is light in weight, which is 0.77 milligrams per square meter. Paper is 1000 times heavier than the graphene. A single sheet of graphene can cover a football stadium while weighing under 1 gram. Graphene is also highly flexible and can be bent or twisted without breaking it. This flexibility is due to the two-dimensional nature of material, which allows it to bend and flex without undergoing significant plastic deformation. Graphene versus other allotropes. On the top left, you can see graphene. Graphene is a two-dimensional material made up of single layer of carbon atoms arranged in a hexagonal lattice as shown in the figure. As you can see graphite on the top right, it is a three-dimensional allotrope of carbon composed of many layers of graphene stacked on top of one another. On the bottom left, you can see nanotube. Carbon nanotubes are another two-dimensional allotrope of carbon, similar in structure to graphene, but rolled into a cylindrical shape. And lastly, you can see fullerene on bottom right. It is also known as buckyballs. It is a spherical molecule made up of 60 carbon atoms arranged in a pattern similar to a soccer ball. Coming into applications of graphene, graphene can be used as filters. By having very precise control over the size of the holes, filters could outperform other techniques of desalination of water by a significant margin. Furthermore, it can be used in ethanol distillation. Graphene oxide membrane allow water vapor to pass through but are impermeable to other liquids and gases. It can be used in energy storage devices. Due to its extremely high surface area to mass ratio of graphene, it is believed that it could produce supercapacitor with great energy storage density. Graphene has several potential applications in solar cells due to its unique electrical and optical properties. Graphene is used in solar cells due to its transparent conductive electrodes, anti-reflective coatings. And also, graphene can be combined with other materials to create a hybrid structure with unique properties, which will increase the solar efficiency. Due to its high carrier mobility, it can be used in integrated circuit. Graphene is used in optical electronics, devices such as touchscreen smartphones and organic LED. Due to its lightweight, it can be used in aircraft and other vehicles. Let's talk about how does solar panel work. Solar panels work by converting sunlight into electricity through a process called photovoltaic effect. The basic components of solar panel include photovoltaic cell, a frame, a glass lens, and wiring. When sunlight hits the solar panel, it excites electrons in photovoltaic cells, causing them to move and create flow of electricity. The photovoltaic cells are made up of semiconductor material, typically silicon. The generated electricity is collected through metallic conducting strips which sits on the glass lens. The wire strips used on top of a solar panel to collect electricity are typically made up of conductive metals such as copper or silver and are called bus bars. These metallic strips will block the sunlight to pass through, and this can be eliminated by using graphene. Solar panels require materials that are highly conductive and which allows light to pass through it. The indium tin oxide is used in solar panels, is rare and also brittle, and it's highly expensive. In a traditional photovoltaic cell, light is absorbed by a semiconductor material, creating an electron-hole pair that is separated by a p-n junction. The separated charges then flow through the cell as an electric current, generating power. However, during the separation process, a significant amount of energy is lost as heat, which reduces the overall efficiency of the cell. However, by using graphene to create hot carrier cell, it will capture the excess energy of the excited charge carriers before they thermalize and release their energy as heat. This can be achieved by using graphene, which has unique electronic structure that allows the hot carriers to be maintained at room temperature instead of quickly relaxing to the ground state. Graphene's two-dimensional material made up of carbon atoms arranged in a hexagonal lattice has several unique electronic properties. that make it a promising material for creating hot carrier cells. Firstly, graphene has a high carrier mobility, meaning that electrons can move through the material quickly and efficiently. This allows for the creation of a large number of charge carriers, which can be used to generate a high current. Secondly, graphene has a unique ability to maintain hot carriers at room temperature. This is due to the fact that graphene has a linear electronic dispersion relation near its Fermi level, which allows for the creation of large number of hot carriers that can be maintained in a highly excited state. Finally, graphene has high surface area and it is transparent, which allows for a large amount of light to be absorbed and more charge carriers to be generated. Graphene can be used to improve overall efficiency of the photovoltaic devices. Moving into advantages and limitations of graphene. Graphene possesses exceptional electrical mobility, allowing it to efficiently transport electrons. This property makes it an excellent material for collecting and transferring the electrical charge generated by sunlight in solar panels. Graphene is an extremely thin and transparent material. Incorporating graphene into solar panel and photovoltaic cells can enable them to have a high level of transparency, allowing more light to pass through and reach the underlying photovoltaic layers. Graphene has high strength and flexibility. It is the strong material ever discovered. Graphene is a highly flexible material which makes it suitable for the development of flexible and even wearable solar panels. This flexibility can lead to innovative and versatile solar panel designs, allowing for integration into various surfaces and products. And also, it has got other benefits like it is light in weight and it has large surface area and it's a good electron and heat conductivity. Coming into limitations, large-scale production of highly quality graphene remains a challenge. Current methods for producing graphene are expensive and time-consuming, and also it has lack of band gap. There has been several recent developments in the field. Firstly, researchers have been exploring the use of perovskite graphene tandem solar cells to improve the efficiency of solar energy conversion. In this approach, a perovskite solar cell is stacked on top of a graphene-based hot carrier solar cell, allowing for the capture of more of the solar spectrum and the generation of more electric power. Graphene has been used as a material to enhance the efficiency and stability of organic solar cells. Graphene quantum dots have been investigated as a potential material for use in photovoltaics due to their unique electronic and optical properties. And finally, graphene has been investigated as a replacement for traditional transparent electrodes, such as indium tin oxide, which are used in solar cells and other electronic devices. Finally, to conclude, graphene has high energy conversion efficiency and lower cost solar energy. In addition to its electrical properties such as high electron mobility, graphene also has excellent optical properties, including high transparency and low reflectivity. And graphene has large surface area. Although there are still some cost-related challenges to overcome, overall, graphene has the potential to revolutionize the field of PV technology and contribute to the development of more efficient, flexible, and lightweight solar cells. Thank you.